All right, guys, getting into section 2 of chapter 9, we're going to solve quadratic equations by graphing. So previously we solved quadratic equations by factoring. That was back in chapter 8. Now we're going to solve them by graphing and estimate solutions of equations by graphing. So we're going to talk about something that's called a double root. That's one of the new vocabulary words. So a quadratic equation can be written in the standard form ax squared plus bx plus c equals 0, where a is not 0. Otherwise, if a was 0, it would just be bx plus c, which is a linear equation. So to write a quadratic function as an equation, replace y or f of x with 0. Recall that the solutions or roots of an equation can be identified by finding the x-intercepts of the related graph. Quadratic equations may have 1, 2, or no real solutions. So basically you have to make sure your equation is set equal to 0 and then replace the 0 with a y or an f of x. So here's the different ways graphs could show up. It doesn't matter if it opens upward or downward. It matters where it crosses the x-axis. So you could have two solutions if it crosses the x-axis in two spots. If the vertex touches the x-axis, if the vertex is like right on the x-axis, it's going to have one unique real solution. And if the vertex is above the x-axis and it's opening upward, then it's not going to have any real solutions. Or if the vertex is below the x-axis and it's opening downward, it's not going to cross the x-axis. So there's no real solutions. Now, you don't have to memorize whether it opens upward or downward, above the x-axis or below the x-axis. Just look at the graph. If it crosses the x-axis, then it has one or two solutions. If it crosses twice or once, and if it doesn't, it has no solution. So let's solve x squared minus 2x minus 8 equals 0 by graphing it. So first thing you do, you want to graph the related function. Since this is already set equal to 0, you just replace 0 with f of x, and you have the function f of x equals x squared minus 2x minus 8. And we can use the techniques we did before. We got the axis of symmetry and the vertex by the opposite of b over 2a method. We graphed the y-intercept. We graphed a couple more points and use the fact that there's symmetry. So once you get one point, you can just like flip-flop it, put it on the other side, so forth and so on. So here's the graph. And you can see the vertex is at positive 1. And you can see the graph crosses the x-axis 2 times. So the x-intercepts right here and right here of the graph appear to be at -2 and -4. So we would say that the solutions to the equation are -2 and -4 because those are the values that make the y-coordinate 0. Like this point would be -2, 0. And this point would be 4, 0. Well, how do we check that? We can check it by plugging those x values, -2 and 4, into the original equation. So I set it up, and we're going to do both at the same time. I put in -2 here and 4 here. And when you simplify, you get 0 on both sides. Oops. So that implies that x equals -2 and x equals 4 are our solutions. All right. So as always, here's one for you to try. Go ahead and pause the video. Okay, we're back. So 1a, let's first get the vertex. So it's negative plus 3 over 2 times -1. So that would be -3/2. And then the y-intercept is 18. You just plug 0 in for those equations. And then you plug -3/2 into the equation to get the y value. So that's going to be -9/4 plus 9/2 plus 18. So if we add those up, -9/4 plus 9/2 plus 18, you're going to get 20.25. So if I graph it, I'm going to have -3/2, which is like -1.5, and then 20.25. So if I make these go by 5s, 10, 15, 20, and these go by 1s, then I should be able to do it. 20.25 is right here. Said the y-intercept was 18, so it's right there. And then you're going to have one on the other side here. And then the graph's going to come down like this. And this. Oops. Or like that. So your solutions are right here and here, and that would be x equals -6 and x equals 3. And you could double check them in the graph, or excuse me, in the equation to see that they both work. The second one, if we graph it, the opposite of b over 2a, which would give you 4/2 or 2, that equals the axis of symmetry, which is going to be right here. Then if I plug that into the function, so f of 2 equals 2 squared minus 4 times 2 plus 3. So you get 4 minus 8 plus 3, which is -1. So right here. And then the y-intercept is 3. So that would be right here. And then that's 2 units to the left of the axis of symmetry, so there's going to be another point here. I could plug in when x equals 1, f of 1 is 1 squared minus 4 times 1 plus 3. And uh-oh, I get 1 minus 4 plus 3, that equals 0, so it's right here. And the other point is 1 unit away on the other side. So the parabola looks like this, if you graph it. Okay, and the extra point that I got ended up being the solutions. So the solutions are x equals 1 and x equals 3. Okie dokie. All right, let me clear that off. All right, so the solutions in example 1 were 2 distinct numbers. Sometimes the 2 roots are the same number, and we call that a double root. How could you have 2 answers that are the same number? Well, let's solve x squared minus 6x equals -9. Solve it by graphing. So the first thing you want to do is rewrite the equation in standard form. So in other words, I got to set it equal to 0 by adding the 9 to the other side. And then graph the related function and set it equal to f of x. So f of x equals x squared minus 6x plus 9. There's the graph. And you could see that the vertex is right on the x-axis. So the x-intercept of the graph is where, remember, it doesn't have to go on the other side of the x-axis. It just has to touch it. And it touches the x-axis right there. And that's only one solution, and that would be 3. Now, here's the thing. I could check to see if 3 is a solution, and if I plug 3 in here, it would work. But how do I know there's not another one? Maybe I graphed wrong or something like that. Well, another way we could solve an equation, besides just plugging in numbers, was by factoring. So I need, since the leading coefficient is just 1, all I have to do is find factors of 9 that add to -6. Well, that'd be -3 and -3. And you see it has the same factor. So it's like a perfect square trinomial. And, you know, if you set them both equal to 0, you're going to get the same answer 2 times. So the only solution here is 3. Okie doke. All right, here's 2 more for you. Go ahead and pause the video. Okay, we're back. So 2a, you have to set equal to 0 first. So make sure you put it in standard form. Subtract the 10x to both sides, plus 25 equals 0. And then graph the function f of x equals x squared minus 10x plus 25. So I'm going to let these go by 2s. 2, 4, 6, 8. The axis of symmetry is the opposite of -10 over 2 times 1, which is going to be 10 over 2, which is 5. So the axis of symmetry is right there. The y-intercept is 25. So if I let these 5, 10, 15, 20, 25, if I let these go by 5, there would be a point here and another point symmetrically on the other side. So let's do f of 1. That's usually easy. So it'd be 1 squared minus 10 times sorry, I messed up. Let me get back there. Minus 10 times 1 plus 25. So that's going to be 1 minus 10 plus 25. So that's 16. 5, 10, 15. 16 would be right there. And then on the other side, right there. All right, and when you graph it, you get that point. Okay. Also, if you plug in the vertex, or excuse me, the axis of symmetry, f of 5 would be 5 squared, which is 25, minus 10 times 5, which is minus 50. So you get 25 minus 50 plus 25, which would equal 0. So that'd be that point right there. Or you can see the graph, the vertex is right at the right on the x-axis. So the only solution to this equation would be x equals 5. Okay. 2b, got to put it in standard form. So x squared plus 8x plus 16 equals 0. So we're going to graph the related function f of x equals x squared plus 8x plus 16. The axis of symmetry is the opposite of the b value divided by 2 times the a value. So that gives you negative 4. I'm going to let these go by 2's. So the axis of symmetry is right there. F of negative 4 is going to be negative 4 squared plus 8 times negative 4 plus 16. So you'd have 16 minus 32 plus 16, which equals 0. So your vertex is right there. Okay, so I know that's the minimum or the maximum. Since the leading coefficient, or the x squared, is positive, I know it's going to open upward. The y-intercept is when you plug in 0 and you get 16. So I'm going to let these go by 4's. 4, 8, 12, 16. So you would have a point here. And then since it's symmetric, you'd have a point on the other side. And then connect it with a smooth curve that looks like a parabola. And so x equals negative 4 would be the only solution, and it's a double root. Okay, and both of these, when you set them equal to 0, you could factor them. The first one, you would get x minus 5 quantity squared, and this one you would get x plus 4 quantity squared if you factor them. Cool? All right, sometimes the roots are not real numbers. Quadratic equations with solutions that are not real numbers lead us to extend the number system to allow for solutions of these equations. These numbers are called complex numbers, but you're not going to have to know complex numbers. We'll get into that in Algebra 2. Just know that if there's no solution, okay, there's no real solution. All right, so let's solve 2x squared minus 3x plus 5 equals 0 by graphing. So it's already in standard form, so I just write the function 2x squared minus 3x plus 5. If I graph it, you can see that it's a parabola opening upward but does not cross the x-axis, so there's no solution. And you just write a 0 with a slash through it. Okie dokie. Now let me show you a little trick for these. So 3a, the related function, oh wait, pause the video. You try this on your own first. Okay, we're back. All right, so f of x here would be negative x squared minus 3x minus 5. Okay, if I set it equal to 0 and replace f of x, replace the 0 with f of x. Then the vertex would be the opposite of b over 2 times a, which is negative 3 halves. So this is 1, that's 2, negative 3 halves is right here. Okay? Now, I know that since the leading coefficient is negative, it's going to open downward. So I just have to make sure I know where the vertex lies. So if I do f of negative 3 halves, that would give you negative 3 halves squared minus 3 times 3 halves minus 5. Okay, so that's going to be negative 9/4 plus 3 halves minus 5. So if I figure all of that out, negative 9/4 plus, it's going to be 9 halves. 9 halves minus 5 gives us negative 2.75. So that'd be down to be right here. But I know it opens downward. And also you could see that the y-intercept is negative 5. So that would be down here. The other one would be over here, and it's going to open like that. Okay, but once you get the vertex, if you know if the parabola opens upward or downward, you can determine if it's going to cross the x-axis or not. Since the vertex is below the x-axis and the leading coefficient is negative, I know the parabola opens downward, and therefore it's not going to cross the x-axis. So my answer is a 0 with a slash through it, no solution. Okay, so 3b, the related function is negative 2x squared minus 6x minus 8. Alrighty, so the vertex is at the opposite of b over 2a. So if you simplify that out, that's going to be positive 6 over negative 4, which again is negative 3 halves. So like that. If I plug that in, you get negative 2 times negative 3 halves squared minus 6 times negative 3 halves minus 8. So negative 3 halves squared is positive 9/4 times negative 2 is going to give you negative 18/4 plus 18 over 2 minus 8. So that's going to be negative 9 halves plus 6, no, not 6, plus 9 minus 8. And if we figure that out, negative 9 halves, 9 minus 8 is just 1, so negative 9 halves plus 1 is negative 3.5. So here's 1, 2, 3, negative 3.5 is right there. Since the leading coefficient is negative, I know it's going to open downwards, so there's not going to be any solution, because if the parabola's vertex is below the x-axis and it opens downward, there's no chance it's going to cross the x-axis. Okay, so there's no solution there. All right, guys, that's it for this video. Thanks for paying attention. I know graphing those takes a little bit of time, but it's all worth it in the end. All right, stay tuned for the next video.